Here we have an old exam problem that involves temperature change, axial deformation, and stress as well, normal stress. So let's look at it real quick. So, as you can see, it's 35 points, so it was one of the harder questions. Rod CD is made of T6 aluminum and is housed in a rigid assembly. So I guess they tell us T6 aluminum because we were given a table and we had to determine what E and alpha were based on the aluminum, which I kind of just wrote it in here for us. When the temperature is 30 degrees Celsius, the gap between the rod and the top of the housing is 1 millimeter, so that's right here. Determine the normal stress in the rod if the temperature rises to 130 degrees Celsius. So, the very first thing I always do is write down what is given to us. So we have our E, we have our alpha, we have T1, T2, and delta total. So that is this deformation right here, the 0.1 millimeters. And we know that because we have a temperature change, our delta total is going to be equal to the delta CD plus delta due to temperature change. So I just did 0.1 millimeter equals PL over AE plus alpha delta TL. So alpha delta TL, we can determine that right away. We know our alpha, we know our change in temperature, and we know L. The only thing we are going to have to determine here is P, which is the unknown. So I drew an overall reaction here when the rod extends so that it touches the wall up here. And we basically have two forces, one is PC and one is PD. I drew them randomly pointing inward. And so the overall reaction in the y direction gives us that PD is equal to PC, and I just called that P. So they're both equal to each other. Now, if we cut the rod halfway, we end up with a normal that is equal to negative PC. So we have a negative PC, and we know that the total equation is this right here. So I just plugged in everything, all of the numbers that we know, with a negative PC. So the sign is very, very important. And once again, once you proceed to calculate all of this, pay attention to all of your numbers. Make sure you're plugging it into the calculator correctly, because it can create problems for you and give you the wrong answer, and then it just becomes a mess. So I end up with PC equals 2.796 times 10 to the 5th newtons, and we said that PC is equal to PD, so they're both equal to this value. Now, in the end, they ask us for the normal stress of the rod, so we found the value, but we always need to pay attention to the sign. So once again, our normal stress, like no matter which way you draw it, no matter which way you cut it, if you choose to cut it this way and take into consideration PC, we end up with N equals negative PC. Or if you do it the other way, it doesn't matter, you get N equals negative PD. So you know that your N is going to be a negative number, so you plug that in here and you get the normal stress in CD equals negative 142.3 megapascals. And this just means that our rod will end up in compression. And that's our final answer. Yeah, for this problem, the biggest issue is definitely the signs.